Hello class, it's Mr. Cowboy here again, and today I'll be presenting to you a lesson on midpoints and medians in triangles. So these are new terms for you here. So this is going to be really fresh here. All right, so before we begin, make sure you have a ruler handy because one of the examples that we will be doing today, I'm going to have you draw something. Yay. So again, just make sure you have a ruler handy when we get to that example. All right, so let's get straight to it and see exactly what midpoints and medians are. Now, if you break down the two words there, okay, specifically midpoint. Okay, if you break the word midpoint into its two separate parts, you have mid and then you have point, and that's exactly what it is. Okay, a midpoint is referring to a middle point somewhere. Okay, so we're going to talk about what that is. Okay, and median, again, when you're looking at that, median is just another word that you can use for the middle of something. Okay, and like I said, it's going to be really relevant once we start looking at what those two are. So we're going to define that and see how we can actually use those two pieces of information to draw things on a triangle. All right, so let's first define what they are, so you know exactly what it looks like here. And what you first need to know about a midpoint, as I said before, okay, it's a middle point. So it says here, a midpoint is a point that divides a line segment into two equal segments. So if you take a look at the diagram here, okay, we actually have two midpoints. Okay, we have one on the left that I plotted there in red, okay, and another one that I've also plotted in the red. Now, just to use the definition so you have a better understanding what that is, if you look at this point on the left side here, so this would be the midpoint of this line segment here that I'm using the cursor just to outline here. So what that means here is that this midpoint is going to cut this side into two equal parts. So that's why you have those two dashes here. Okay, and the same token here, if you take a look on the right side here, we have another midpoint here, which tells us that this is now the middle point of this line segment on the right. And these two sides over here, okay, are going to be the same side lengths, the ones with the one dash here, all right? Now, there's going to be a relationship that exists between this line over here going from left to right, okay, and the very bottom line that's also going from left to right. And basically what you have here is that a line segment that joins the midpoints together of two sides of a triangle is parallel to the third side and half as long. So that's what that L and the 2L represent, is that they're just going to be a factor of 2. Okay, depending on which number is given to you, you're either just going to multiply it by 2 or divide it by 2. Okay, and you're going to see that once we see some numbers in the examples we're going to look at today. And all we need to know about the height here is that the height on both sides there, okay, will be the same here. So if you take a look at this line segment here and this one over here, okay, the height of this triangle, as you can see, okay, both of these, the dotted lines here, these two would be the same side lengths as well. Okay, so you're going, like I said before, what you want to just take a look at here again is just how all the relationships relate to each other here, and see how we can go from one measurement to the other. All right, so that's midpoint. Okay, the next thing here we're going to look at here is what's called a median. Now, as I said before, median has to do with the middle of something. And how it what's important in terms of what you need to know of terms of what a median is obviously what it is, but also how it's constructed. Now, how a median is constructed is that when you take a corner of any triangle, okay, which I represented there with the red dot, what a median is from that corner, you're going to draw a line to the opposite side, and it cuts the opposite side exactly in half. So if you take a look at what I have here, okay, the median is this line in red. So we started off from this corner, drew a line directly across to the opposite side, cutting the opposite side in half. Okay, so any line that goes from one corner to the other side that cuts that other side in half, okay, that's an example of a median. So for example, if I'm just going to do this in blue over here, if I were to choose, let's say, the top part over here, the top corner, if I drew a line, okay, that cuts this triangle exactly in half here, I'm going to try my best to draw a straight line, okay, then this here would be the median. Okay, so you can see here when you're drawing medians, you're just drawing it to the opposite side and cutting the opposite side in exactly the same measures there. Okay, so I'm just going to do it like that. Okay, so that's going to be an example of how a median works. Now, what a median does to a triangle is it cuts the area in half. Okay, so you're going to see that depending on what area is given to you, you're either, again, going to multiply by 2 or divide by 2. All right, the last thing we're going to look at here, this is the part that may be a little bit challenging at first, is we are going to learn how to construct what's called a counter example. Now, we're going to approach it the same way that you would, for example, an English essay. So when we get to the example, you will see how we're basically going to do that, but using math. All right, so let's get straight to it over here. And let's start off with the first example, okay, that deals with midpoints. So it says here, determine the length of a line segment BC, okay, given that information that you see in this diagram over here. So as I said before, when you're looking at midpoints and they're joined by a line here, the relationship between the two parallel lines here, x, y, and bc, okay, is just by a factor of 2. Now you notice that what we have to do here is knowing the fact that xy is half of bc, or another way to look at it is that bc is twice or 2 times longer than line segment xy. So all we have to do here is to take the 16, okay, multiply it by 2. So line BC here will be 32 meters. All right. So again, that's just applying the relationship when it comes to connecting lines with midpoints. All right. So let's take a look at another example here. Okay. You notice this is very similar. The only difference is that I have to have a triangle that happens to have a different orientation. So what we have here is we want to find out the length of line segment WV. And in this example, notice that what we have here is the measurement of the longer side. So all we have to know about this here is that the line segment XY is twice as long as WV. Another way you can look at it here is that WV is also just half the length of X to Y. So what we're going to do here, we're just going to take the 18 divided by 2. So WV will have a line segment of 9 centimeters. All right, so again, that's, as you can see here, we just applied the relationship again with the midpoint and the midpoints joined by a line segment. All right, moving forward. Okay, let's take a look at this one here. This time we're dealing with medians and what it does to the area of triangles here. So it says here, a median bisects the line segment PR. Okay, so remember what a median is from one of the corners of a triangle, you're going to draw a line directly to the opposite side, cutting the opposite side in half here. So that's what the word bisect means, is that you're cutting something in half. Now what we have to know here is that triangle PQR has an area of 64 square centimeters. So we know what I've outlined there in red is going to be 64 square centimeters. And what we want to do here is to determine the area of PQS, which is half of it, okay? So again, the whole triangle is 64 square centimeters, and we just want to know and figure out the area of the smaller triangle, which, as I said before, is exactly half. So all we're going to do here is take the 64, okay, divided by 2. So the area of triangle PQS here will be 32 square centimeters. All right. So as I said before, when you're dealing with medians and when it bisects a line segment, the area, depending on what information is given to you, is going to be changed by a factor of 2. All right, you either multiply or divide. Okay, so in a similar fashion, same triangle, different information that we have here. So it tells us here that triangle QSR has an area of 12 square centimeters. Okay, so I've outlined in there blue. We want to find the area of the entire triangle. Okay, triangle PQR. So notice that what we have here is that the smaller triangle is 12. So we need to find the area of the bigger triangle. So all we're going to do in this question here is to take the 12 and multiply it by 2. So the area of the entire triangle here will be 24 square centimeters. All right. Okay, so before I proceed to the next screen here, make sure you have your ruler handy. Okay, and what I want you just to think about when we're looking at this question, like I said, this is going to be really, really new here, is we want to create what's called a counter example. Now, I mentioned earlier in the beginning of this lesson here, we're going to treat this like we would an English essay. So you know when you construct an English essay, typically you have the introduction, okay, where you talk about what you're going to talk about. You have the paragraph that makes up the body, and then you have a concluding sentence. Okay, so what we're going to do here is we're going to approach it the exact same way by reading the question. And what we want to do here is to prove it wrong, but not using English for the most part, but we're going to do it mathematically here. All right, so let's read the question. and see what we're talking about. Like I said, this is a little bit difficult to wrap your head around, but you're going to see that when we approach it, we'll be able to do it using pictures. All right. So DeAndre measured this right triangle and noticed that a median bisects the right angle. He conjectures, he guesses, that a median will bisect the right angle in all right triangles. All right. So I want you to just pause the video here for a moment, and what I want you to draw for me, okay, is a right angle triangle, meaning one of your corners must have a square in it. Okay, so I want you to draw a right triangle, okay, and make sure and make it very clear that all three sides are different lengths. Okay, take a moment to do that. All right, so I hope that you drew a right angle triangle, well, where all three sides happen to have different lengths. Okay, make sure you correctly identify which corner has a right angle, and I want you to do it with a box. All right. Now, what I also want you to do now is take the measure of the longest side, which you probably know as hypotenuse, and I want you to measure exactly, okay, the middle point, and then wherever the middle is, okay, I want you just to draw a point there. All right. Okay, now what I want you to do there is to connect that point, okay, and I want you to draw it to the corner where the 90-degree angle is. All right. Now, once you do that, let's talk about this question. So what I want to do here, again, is to take a look at the diagram, analyze what this question is dealing with, okay? Because if you read the question very carefully, okay, the diagram here is correct. So let's break this down. So it says DeAndre measured this right triangle, okay? As you can see, we have a right triangle because we have two angles that add up to 90. So this would be the right angle, okay? And he noticed that a median bisects the right angle. So remember, a median is a line that extends from one corner, okay, which in this case here is the top corner, okay, and it extends to the other side, which it does, and it cuts that other side into two equal parts. So notice that what we have here is a correct diagram, okay? He conjectures that a median will bisect the right angle in all right triangles. Now, according to this diagram, guess what? That sounds true. Now, what I wanted, I remember I had you draw a triangle where all three sides were different, okay? So what's important for this one over here is that now I want you to see why, well, this diagram does look right, but if you compare it to your diagram, it might look slightly different, okay? And the reason for that, okay, and this is why their conjecture is incorrect, is that fact that, yes, you know what, based on how he's drawn this, okay, it's true. However, this is a very specific type of triangle. Notice that in this triangle here, we have two sides which are equal, and the opposite side happens to be different here. So this is, again, an example of an isosceles triangle here, okay? So, for example, I had you draw a triangle where all three sides were different, okay? And when you took the midpoint, okay, of the longest side, which was this one over here, and you drew it to the corner of the box, okay, most of you probably drew a line such that it cut through the box somewhere else, that's not in the middle. So this over here tells us that what we have here is the fact that the median does not bisect the angle, because as you can see in the diagram, in the box over here, okay, these are two different areas here. So again, this particular example that DeAndre used, okay, only applies when you're looking at isosceles triangles. Okay, when you have all three sides which are different, which is a scalene triangle, okay, then it does not apply. So this is an example, okay, of a counterexample. All right. So going back to the English essay, so this would be an example of what you would do in the body is to prove your statement correct, or you back up your statement or intro, and then you could um, prove another statement incorrect, someone else's essay, for example. Okay, so you can see that how that relates to math in this example. All right. Okay, so that wraps up this lesson. So I will see you in the next one.